I would like to just say thank you for coming. This is a special colloquium, as we have already advertised, and it will feature presentations from students that actually have participated in our 2021 summer research program this past summer, and it was supported by Blair Jones Endowment. So this program supported 10 or 9 students, I think 9 students overall, and a lot of them were from local high schools, rising juniors and seniors. So today you will hear 3 presentations from these students, and the other students will display posters. So be on the lookout for posters in our hallways or on the screens. We're still trying to figure out what's the best way to display it. So I hope you will enjoy our presentations. And Michael, stage is yours to introduce your student.
Very good. Thank you for that nice introduction, Julia. So welcome, everyone. Glad to see everyone here and excited to hear about all the talks and the research that you guys have been doing over the summer. So Max did a project in sonar with me over the summer and came to me kind of asking, hey, what could I do that's kind of engineering flavored? So this is what developed. We had a lot of fun exploring acoustic properties of materials. Got to build, got to analyze data, and got to program some Python. So, Max, unmute yourself and take it away.
All right. Can everyone see my screen?
Yep. Awesome.
All right, great. Good afternoon, everybody. My name is Max Calteri. I'm a senior at Wilson High School in Tenleytown. And like Dr. Robinson said, this summer I did a project where I got to build a homemade sonar system and test the acoustic properties of different materials, how they interact with sound waves. And the goal was to answer the question, if you talk to these materials, will they talk back? So the use of different material is seen all around us to change how sound waves interact with their environment. And this is used in concert halls, which want to amplify and direct sound waves in certain ways. Also used in recording studios that want to dampen echoes off walls and ceilings. And this can give the illusion of a much larger space than is actually being used. So this gives much less echoes for recording certain types of music. So this project will analyze different materials and how they interact with sound, which raises the question, what material will produce the least echo? So the process behind this project was to first create the sound that I would use to test the echoes off different materials, then build the physical sonar system used to test, and then test the actual materials. And these materials I was using were going to be plywood, tile, foam, and fleece. And then after that, after all the data was collected, the goal was to analyze it and see any trends. So first step was to make the sound. And so using Python, I created a sound that has 10 pulses, each with a pulse width of 0.1 seconds. And so these pulses started at a frequency of 200 hertz and then swept up to 600 hertz. And so this allowed to see the most, the difference in the frequencies off the material. So you can see a wide range of how the materials interact with different frequencies. And this sound sounds like this. And so this was to be sent out of a speaker, as shown in this. You can, it will be sent out of the speaker, hit the sample, and then echo into the microphone. And the microphone would read all of the echoes and see how the sound interacted with that sample. So the first step in the building process was to build a microphone cone. So this microphone cone's job was to condense and direct all of the sound waves into the microphone, into a central point at the microphone. And this was composed of 4 triangular plywood pieces that created a pyramid shape to funnel all the sound into the microphone. And then next was the speaker box, which had the exact opposite job of the microphone, of the microphone cone. So this had a very similar shape to the microphone cone, except its goal was to direct the sound out of the box and at a location which I could control based on the angle of this speaker box. And so this was to be aimed at the sample and then which would bounce off into the microphone cone. The preliminary tests were done with only plywood and foam to see if the test setup worked. And so for these tests, I kept the 1 meter separation between all of the testing materials, and I played the sound at full volume. And what I found here was that there was some irregular data. As you can see, the first pulses shown have very harsh stopping points, and the next pulses, you can see these echoes off of the box, which were a problem because the pulses are supposed to stay consistent throughout. And so there's no echoes shown in the first pulses, but there were echoes shown in the second pulses. And so the problems that arose here could have been due to multiple reasons, but the things that the possible reasons were the unwanted echoes in the speaker box, a skewed vertical angle of the testing setup, and the distance of the sample from the wall in the couch. So this could have caused the echoes to be echoing off the couch and the wall instead of actually echoing off the sample. And it also, the skewed vertical angle could have caused the sound waves to be directed in the wrong direction. So the first step to fixing these problems was to fix the speaker box. And so the solution I came up with was to line the speaker box with foam so that unwanted echoes wouldn't bounce around the speaker box before exiting at the sample. So this would cause all of the pulses to be the same length instead of having echoes that resided in the box exit the box later. And so in the second round of testing, after insulating the speaker box, you can see that the pulses were much more consistent and they stayed the same throughout the entirety of the sound being played, which showed that the problem was, in fact, that the speaker box was holding sound and then only releasing it towards the end. After the second round of testing, in which we used all materials, the dimensions stayed the same, but we did rotate the testing setup 90 degrees so that the wall was further away from the sample. But this was also done at full volume. And as you can see in these sound waves, they have a flat top on them. And this means that my microphone was not able to pick up the full range of the sound being played. And because it went out of the range of the microphone, it was harder to test for the differences between materials. So the fix to this problem was simply just turning down the speaker that I was playing it from. And so as you can see, as I decreased the volume in the speaker by 50%, I was able to get much less of these capped blue, dark blue areas and much more of the actual shape and sound profile from each sound being played. And so the final data was collected for foam, plywood, fleece, tiled drywall, and one control with no material in the way of the sound waves was collected. And then the data was compressed using the fast Fourier transform and then averaged to get a graph with differentiable results. So here we can see the raw data. So in this data set, the pulses are shown on the y-axis and the time samples are shown on the x-axis. And also the strength of the sound is shown based on the color in the data, with the yellow being stronger sound, meaning more decibels of sound, and the green being a weaker sound. So next, we compressed the data to make sure we focused on the frequency that was actually wanted. So my sound is being played anywhere from 200 to 600 hertz. So this means that anything that isn't 200 to 600 hertz is most likely excess sound that is unneeded and unwanted. So this fast Fourier transform was able to kind of laser in on these frequencies, so I could only be looking at the data that I'm testing for. Next, we shifted the data to line up and synchronize the microphone and the speaker and synchronize all of the different pulses we used. And so it was also focused more on 0 to 200 or 2,500 time samples. And we know that based on the speed of sound, which is about 343 meters a second, and the distance that the sound had to travel, which is 2 meters, we know that the echo will be shown up anywhere between 200 and 600 time samples. So here we are able to zoom in further on those time samples. Next, that was averaged to get a line graph between all of the pulses. So now the signal level is shown on the left, and this is measured in decibels, and the time samples are still shown on the x-axis. So this is an average of all the pulses that is much easier to read. So then next was to analyze the shifted compressed data averages so that the differences could be seen. And as said, we know that we have to look between about 200 to 600 time samples to find the echo. So if you look here on the graph, this is where the echo is going to show up. And this is a control which has no echo because there's no sample being tested in the control. So there's actually just blank space with nothing for the sound to bounce off of. Next shown is the plywood. As you can see here, there's some echo shown between 200 and 600. then the drywall, then the fleece, the tile, and then finally the foam. And so to put it into numbers, we have the control, which has if we average between 200 and 600 time samples, the control recorded 206 decibels of sound. The plywood, drywall, fleece, and tile all averaged 224 decibels of sound, and the foam had 208 decibels of sound. So in conclusion, the foam produced the smallest echo that averaged about 16 decibels less than all of the other materials. So the foam had nearly the exact same echo profile as the control variable. So as we can see here, if you look between 200 and 600, the foam has no spikes. If you look at the control variable, there's also no spikes between 200 and 600 time samples. So what this means is that if you're trying to remove echoes in a studio, foam is definitely the best choice because it gives the illusion of a much larger space. If you're using foam, it is essentially like there's no walls there at all. There's only 2 more decibels on average here than with a control variable that is nothing at all. So if you want less echo, you should definitely use foam. So the work carried out in this project was supported by the Blair Jones Fund, the AU Department of Mathematics and Statistics. Thanks Blair Jones for the generous donation and continued support for the department. And I'd also like to thank Dr. Robinson for being such a great help this summer. He definitely made this project more fun than it could have been. And he gave me lots of insight into college research in general, and it was really a great experience for me. Thank you.
Thank you, Max. This was great. And I have a question now for Dr. Robinson. Can I be your student next summer? Because I like this fun project you always do with students.
I'd also like to compliment both Dr. Robinson, but especially Max on that was an incredible project. You have several career options ahead of you. The fact that you can program and do everything in Python, leads well. You could be a computational scientist, you could be a mathematician, but I was really impressed with your carpentry skills. I mean, I thought those boxes were very well put together. Oh, Michael, you should have encouraged him to dovetail the boxes. That makes a tighter seal and a more, orthogonal composition. But I'm going to mention a movie, and the movie's called Hustle and Flow. So this might be something that only some of the high school students wouldn't know about, but it's a phenomenal movie. It stars Ludacris, and they make a homemade studio in Nashville. I mean, not in Nashville, in Memphis. And they use not only foam to line their walls, but foam that looks kind of like egg cartons. So the foam had indentations in them. I've also seen homemade studios. I hang out with a lot of musicians. My family has musicians in it, and lots of my friends are musicians. And you can also use good old-fashioned egg cartons as a dampening. And the realization there is not only the substance, but the surface. The fact is, if you have a surface which is, I don't know, how would you describe it? Highly oscillatory and up and down like an egg carton, that can effectively dampen because it creates something Dr. Robinson will know about, multipath within the little cartons and a lot of cancellation that way. So this might be a fun experiment to do with that if you guys want to present at the Matthias conference, which I strongly recommend in the spring. And Max, you have that was a fantastic project, and you have a very bright future in front of you.
Thank you.
And see the hustle and flow.
Can I ask a quick question? So was the fast Fourier transform critical for your analysis, or could you have done without it?
It was definitely critical for the analysis because I tried my best to have a silent room with no feedback from my microphone or speakers. But in reality, there's just too much going on for me to get the complete quiet that I would like. So this was able to definitely give me a better look at the frequencies that I wanted to see. So all the other frequencies didn't really matter to what I was testing. So using the fast Fourier transform was able to get me that nice differentiable visual data that showed me the differences in those echoes.
Thank you.
Do we have any other questions? No questions? Well, let's thank Max again. That was great. And let's move to the next speaker. So Richard, the stage is yours.
Thanks, Julia. So I'd like to introduce Zeline Desiree. Zeline's going to introduce herself, but she signed up to do a project about using open data to understand your community. So Zeline, if you're able to turn on your video and share your screen from the school library there.
Hi, I'm Zeline. I don't think I can share my screen. I'm using my iPad. Is it okay? Would you be able to do it?
I will share your screen. Give me
Thank you
1 second. Let's see if I can. Nope.
Also, sorry for the noise in the back. I'm in like a post-op room in my school's library.
Why don't you start talking while I figure out how to get this PDF?
Okay, well, while he does that, hi, my name is Zeline Desiree. First off, I hope you guys have had a good day thus far. I attend Georgetown Visitation. I'm still in uniform. And for my research, since it was about learning about your community through open data, I focused on Prince George's County, where I am from. And I decided to look into unaffordable housing in the county. It was such an interesting project. I really enjoyed it. I got to learn so much about statistics that really is going to help me throughout the school year and in my future. It ties into what I want to do in the future, which is just like political science and also political science, public health, and just like social justice in general, and seeing why some injustices happen and really understanding the history, the statistics behind it, and all that other stuff. So once we get the poster up, I'll be able to explain that more. But we did this project over 8 weeks, and so I really got to had a good time period over the summer to go over this stuff. So, yeah, about 2 weeks we researched open data and learned just about different kind of programs to use. Then for about 3 weeks, we collected data, and I kind of got what data I needed. And then after that is when I started to really test my data through the linear regression on Excel. And I got some really interesting results.
I had to open up. I'm almost. Let me find back Zoom.
Great. Okay. Again, thank you guys for joining me. Like I said, I looked at why unaffordable rental housing in Prince George's County, Maryland is so pervasive. I found that data from the Census Bureau's American Community Survey does little to explain the difference in rate of unaffordable rental housing across Prince George's County zip codes. This suggests that Prince George's County policies may affect rental housing more than in the individual situation. In my presentation, I will explain the approaches that I used, display my data, show results, give my conclusion, and give recommendations of next steps. Along with the main finding, I developed a hypothesis that said over time, Prince George's County has become slightly less affordable, and the demographic information in the American Community Survey would be able to explain the pervasiveness of unaffordable housing in the county. So we asked ourselves two questions, kind of like how my hypothesis is broken up into. My first question was about if the Prince George's County rental affordability from 2014 to 2019 changed. I was trying to look for a continuity or change over time. Also, did demographic data explain the different rates of unaffordable housing? And we also developed a rate. So when I say unaffordable rental housing, I meant that the gross rent is either greater than or equal to 30% of the household's income. I worked with Dr. Essler, and we created that rate that I just said. We used a numerical and graphical analysis in Microsoft Excel to investigate the relationships between the variables and use the linear regression, like I said before, to plot and assess my hypothesis about the relationships and examine the assumptions. I just want to specify that we looked into rental affordability in this project. So the American Community Survey variables that I looked at was college education, race, white and Black, citizenship, work commute length, ethnicity, means of transportation to work, health insurance, and number of earners and median age. So with all those variables, 10, I think, only one out of those 10 worked, and we'll see that here. In my results, I found for the first question, I answered that from 2014 to 2019, over 50% of householders, rental householders in the county were in fact struggling with unaffordable housing, which went with what I was saying, my hypothesis. Here's two examples from two zip codes is that in Acrosco, over 90% of the householders experienced unaffordable housing in both 2014 to 2019. So there was like a continuation of that. But in Glendale, we saw a significant drop in unaffordable housing from 91% to 27%. Answering the second part of the question, we got that only a percentage of householders with one or less earners, only the percentage of householders with one or less earners explain the relationship and the differences in zip codes in the county. So we deduced that there wasn't many demographic information that could explain unaffordable housing in the county. So that, which kind of makes sense. So more earners the more people that are earning in the house would be able to pay for the house more, which kind of made sense. So it wasn't surprising that that would probably be the only variable we found that correlates with unaffordable housing. For my conclusion, I stated, I'll go over the data first. So on the left, I kind of try to find the relationship between unaffordability in 2019 and 2014. And I use the adjusted R-squared value, which gives the rate of relationship variance between the dependent variable and independent variable. So there's about 13% of that had a relationship. So that's actually pretty good because when it comes to human things, they aren't going to be perfect. So to have that is a pretty good determination that there was a little bit of variance. And on the right, we see the number of earners in unaffordability, and that was about 40%, which was a little better. So we see that there was a little bit more relationship between those. And compared to like maybe other variables that I looked at would have not even close to a percentage point of relationship. So that shows that the earners actually was the only variable that had any kind of relationship. So I concluded that unaffordable housing in Prince George's County does not vary based on demographic characteristics. So that basically says that it's more than just the individual that is affecting their housing circumstance. It's probably something more systemic, maybe like policies. And I recommend that Prince George's County should develop policies that provide resources to produce and sustain affordable housing, which would attract developers who can provide jobs for the residents and create incentives for home buyers. As we go on to the next step to see if I would continue this project, I would try and look at unaffordable housing for mortgage payers, and also look at the zip codes that improved from 2014 and 2019 to see what they did right, or even look at the inverse to see what happened, what didn't go right in some counties. I would like to thank the Blair Jones Fund for providing so much help in supporting my project. Also, I would like to thank Dr. Ressler. He has been such a great mentor for this. I really enjoyed my time doing this. And lastly, I would like to thank you all for listening to my project. I really enjoyed researching this topic, and I hope you all enjoyed listening to it. Thank you.
Thank you, Zeline. That was very interesting. Do we have any questions?
Yeah, I have a question. So you just looked at Prince George's County, is that right? So have you thought about if this trend is holding in other counties, if it's true in Montgomery County, or if in Southeast or Northwest? Have you considered seeing if this trend of unaffordability is pervasive across the entire DMV, or if it's just certain counties?
Well, yeah, for this, I just looked at Prince George's County, but what made me want to look into this more is what I knew about DC and knowing how housing in DC is. I know DC has a large gentrification issue, and so I know that would translate into unaffordable housing there. So I wanted to see if in my own county that same thing was happening.
Yeah, for sure. I'm in Alexandria City in Virginia, and I'm sure it feels like everything is unaffordable as well over here.
Yeah, Zeline, excellent presentation. I was about to also ask the same question, and it would be interesting to see if you enlarge the footprint to include both, Montgomery and PG, but also I also live in Virginia, and to see how not only county policies but maybe state policies affect this. And I think you'll find kind of a widely varying range. Like I live in a place called Ashburn, and I think the policies in Loudoun County are different from those in Alexandria, and different from those in Fairfax. And I think this can all lend to, this distribution being quite different over the larger regions. And it'd be a very interesting study, because then it would sort of force the policymakers to address this.
I had a quick question to Zeline. Did you ever look into maybe why Glendale dropped from 91 to 27% in affordable housing between 2014 and 2018? Any descriptive statistics that you could provide?
I couldn't really find really good. I did try and look it up, but I did, when I was researching, I did find that Prince George's County came out with, I forgot what it's called, but it was like these initiatives to make Prince George's County a little bit more affordable. I think it's called Housing Opportunities for All. And so maybe what they suggested in that might have helped, but it was in 2019, so I don't think it might have really pushed it to drop that much. But I do suspect the county is doing just a little bit to help out in those areas. But yeah, I wasn't able to find much when I did try and look at Glendale.
So
yeah, thank you for that. I'll definitely dig into that just out of curiosity too. So it's a good point. Thank you.
So a quick question. In one of your recommendations, you want to have incentives for home buying, better loans or something like that. I just wonder how you are thinking. Why would that be a good thing?
I think when I was thinking about that, I looked back into what I learned about history in when I took AP US history. And I think I was thinking about after World War II, what helped veterans when they came back kind of buy homes. And it was creating incentives with like, I think it was subsidized or unsubsidized loans. So something like that, or just things that would push people to even try to maybe buy homes, maybe more than rent it. Maybe that's why I wanted to maybe look into mortgages and see if there was a push, would it help people out more?
But why? Why would it be a good thing? Would it not be a great thing if 100% were renters? Is something wrong with being a renter, or what is your thinking here?
I don't think anything's wrong with being a renter. I think more recently people have been renting more because people have been, not staying in one place. So, but I just think to solve the problem of always thinking about how your housing may not be affordable is to maybe settle and kind of look at it as an investment for the future.
Oh, I see. So it's more control in some sense. Someone else can increase my rent, but if I own it, that can't happen. Something like that.
Yeah, something like
that. Okay, thank you.
Do we have more questions? Okay, let's thank you, Zeline, again for a wonderful presentation and explanations. And Richard, the stage is yours again.
Okay, so I'm going to show a video from Nico, who is a basketball game that popped up today. And so for the next 4 minutes, 48 seconds, I'm going to turn it over to Nico.
Richard, there is no sound.
When you share your screen, sometimes there's an option, like a checkbox that you have to check that says share my sound when you share your screen.
Hi, I'm Nico McClure. I'm a senior at Georgetown Day, and my project was on Prince George's County vaccination rates. I chose this topic because at the end of my junior year, I had a final project for physiology, and it was to research vaccine hesitancy and why some people have the stance that they have. What I found was a lot of the times politics and vaccine hesitancy were intertwined. And I found that very intriguing because politics is something that has always piqued my interest. So when I came into this, I decided to do what demographic factors, if any, can explain the difference in COVID-19 vaccination rates across the zip codes in Prince George's County, Maryland, which is where I've lived my entire life. So after doing some research and reading a lot of articles, I found that multiple factors could actually play a role in COVID-19 vaccination rates. Some of these factors include socioeconomic status, race, and religion. I decided to use data from the Census Bureau to create scatter plots and linear regressions to see if I can find any relationships among the factors and the vaccination rates. Some data materials that we used were from the American Community Survey. Some of those included income, ethnicity or race, education, and health insurance. Prince George's County's website on COVID vaccination rates was by zip code. So with the help of my professor, I learned how to use Microsoft Excel to chop down the data into smaller pieces so it wasn't as broad. So once we obtained the vaccination rates from PG County, we grouped the data by zip codes and we had to chop it down. So when I say that, what I mean is we had to group some of the rates, like for example, education. Some people didn't graduate college, some people didn't graduate high school. So we had to group those together and put those in percentage by each zip code. So once we did that, we created scatter plots with response variables of vaccination rates by zip code, and with each variable to see if any of them would have any correlation. When two variables looked promising, we created a scatter plot and to see if those two variables had any correlation with each other or with the vaccination rates. So what we found was very few variables actually were related to the vaccination rates. Education and income had high correlations with the vaccination rates, but also with each other. And since they were saying the same thing, we didn't need to use both of them. So we just decided to use education when moving forward with the process. We also used race because the percentage of Black or African American had a relationship and was not correlated with education or income. The church data surprisingly had no correlation. That was one that I actually expected to have some correlation, but it might not have been from the actual church data. It might have just been the measure of the data on a county as a whole. Some churches may not have turned in data, or some churches may not be documented. The best explanation turned out to be education and the percentage of African Americans, which had a p-value of below 0.0005 and adjusted R-squared value of 0.47, which turns to 47%. So in Excel, they give you regression plots. And with this plot, if you see the orange dots are actual data, and the blue plots, the orange plots, excuse me, are predicted data, and the Y plots are actually our actual data. And if you look, our predicted is inside, is like inside of our actual data. So in conclusion, the education and race combined could explain 47% of the variation in vaccination rates. And most of the other factors didn't end up showing any relationship. If I was to do this again, I would most likely do more research in terms of where people get their news from or social media, because in today's technology, those things play a huge factor in society and in the community, period. I would like to thank the Blair Jones Fund for funding this project, and American University Department of Mathematics and Statistics for making this whole thing possible. Thank you.
So that's Nico's presentation. I can try to answer any questions if you have, but I can't represent Nico.
Just one quick question.
Yes.
It sounded like he said that he first looked at many variable and found variables that seemed to correlate, and then did a scatter plot, if I understood it.
No, he looked at all those individual variables to try and see if there was any relationship, and only found 3 of them. And he was doing that with scatter plots. So he'd look at the scatter plots in Excel and see what was going on. And then when he found both income and education, he looked at them together and said, well, those are highly correlated. And then he compared, and education actually had a better fit. So then he looked at education and percent African American, and saw there was very little correlation. And so that's why he said, all right, let's run both of them together. And that's how he came up to the 47%.
And Richard, I would think also where, as we heard yesterday, Congress is looking into Facebook and how much they promote sort of polarizing information. I would think a strong factor would be where do you get your news from?
Right.
That would be something, because if you watch the 2 news feeds side by side, it's like they're sort of telling opposite stories about this. And
and from the literature reviews, that's done usually through surveys. He tried a proxy to see if the census data had number of computers in the household, to see if the more computers you might have, but that had no, relationship. And he also looked at citizenship status, however good that data is in the census, and there was no relationship. So he was trying to get to that source of how engaged are people online, but we did not do a survey.
Yeah.
Okay, so good job to Nico. And thanks, everyone.
All right, everybody, let's thank the speakers again. Zelene, Max, They did a wonderful job, and Nika. And thank you for coming. Thank you for gathering and asking great questions. And we hope to see you in 2 weeks for other presentations.